So read along with me up here on the board. Jason, will you read that out loud for us? Everybody listen to Jason.
The probability of an event is a number that represents the likelihood that the event will occur. Probabilities are between 0 and 1, including 0 and 1. The diagram relates likelihoods above the diagram and probabilities below the diagram.
Good. So do you notice how there are 3 forms of the probabilities written in every case? For those of you who were here with me during camp week, you guys saw these probabilities. Or you saw, we represented those probabilities as both fractions, decimals, and percents. Now notice impossible, unlikely, equally likely, likely, and certain. These are ways that we can characterize probability. We can say, oh, that's likely to happen. We can say, oh, that's not very likely to happen. Or, that's like this one, right? Equally likely or not. So it's like flipping a coin, right? That would be a perfect example of this. What's the likelihood that when I flip a coin it lands on tails? The likelihood would be, well, it's equally likely to happen or not, right? It could happen or it could not, right? That's the likelihood of flipping a coin and landing on tails. Can anybody give me an example of something that would be like unlikely to happen?
You win the lottery.
Okay, I would say that that would be almost impossible, right? Winning the lottery would be almost impossible. It's not impossible, right? Because there is a chance that it could happen. That would be very, 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 I would call that very, very, very unlikely. I'd say that'd be like right here. Give me an example of something that would be unlikely. Something that would be unlikely. Yeah.
It snows today.
It snows today, that would be very, very, very unlikely, right? Right, because the temperature.
It's freezing right now.
It rains today, that would be unlikely, because the rain has already passed. I guess what I'm really asking you is, give me something that has a probability of this. Yeah.
You have a bag and you have 4 markers in there and one of them is red and that's the one you're trying to pull out.
Yeah, that's perfect. You have a bag of markers, one of them is red, there's 4 markers in there, one of them is red. It's unlikely that you would pick the red one, right?
Yep.
Because it's a 1 out of 4 chance, 25% or 0.25. Guys, don't forget, decimals and percents and fractions are all equivalent. 0.25. Give me something that's certain to happen. Give me something that's certain to happen, a probability of 1 that will happen.
There's a cookie on the table.
If your parents said you can eat that cookie and there is 1 cookie, what's the probability you're going to pick that cookie? 100%, absolutely. That is certain to happen. I'm going to eat a cookie. There is only 1 of them. What's the likelihood I'm going to eat that cookie? 100%, I'm going to eat that cookie. Right? So that would be, what would be something that's impossible?
My mom saying she loves me.
That's awful. Don't say that. What would be something that would be impossible? Cannot happen. Yeah. Whole class not being here. I would actually venture to say that that is not impossible. Because what if you all got sick on the same day?
That's
How do you know like a stomach bug couldn't just like wipe us out? I would venture to say that would be like this area. Very unlikely. Not impossible. I want something that is actually impossible. The probability of it is 0. Steven?
A tsunami because we're landlocked.
What?
A tsunami because we're landlocked.
Nope, that's possible. Why would a tsunami be possible in Indiana? Lake Michigan. Lake Michigan. Very, 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 very unlikely. I would not say impossible though. Just ask Noah, right, from the story from the Bible, right? Shoot. Right? It's a story, right? It's a story from a book, right? If we take it on face value, let's just take it on face value, not as like a biblical text. Let's just take it on face value as a story. So in the story, the entire earth is flooded. Is that impossible? Well, I don't know. Ask him. In that story, I would say that would be very, 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 very unlikely, right? But just taking it as a story. I'm talking about something that is certain to not happen. It cannot happen. It is impossible. Thinking of impossibilities is actually kind of difficult. Anna?
Yeah, something Something impossible.
No, I have seen a man lift a car.
Well, that's not a superpower.
My dad can.
I mean,
I'm talking about like
I'm talking about something that cannot happen.
You all turn into zebras?
Nope, that could happen.
A dead person going back.
A dead person come back to life. Have you ever seen The Walking Dead?
But that's a show.
Like human beings living without a brain.
Living without a brain? I don't know about that. You can be brain dead.
I didn't know
What is he living? Rolling a 7
Hey, listen up. Hey, listen up. This is what I'm looking for.
Rolling a 7 on a 6 fair-sided dice.
Rolling a 7 on a 6-sided dice.
That's impossible.
That is impossible. That is something that is actually impossible. Or dealing out 53 cards from a deck. That is impossible.
6 and a 1 and a 7.
Or in this class, selecting 60 students. Why are those things actually impossible? Whereas turning into a zebra, while very, very, very likely could be possible. Somebody uses magic.
I love nature.
Don't snooze it. Alright, so let's bring it back in. I want to give you time to do everything. So, this is an important concept. See how difficult it was to come up with something that was actually truly impossible? Now, I know that it's very, very unlikely that you will turn into a zebra, but there is a world where that could happen. But there is no world where you could roll a 7 on a 6-sided dice. That is a 0% chance of happening. That's tough to think about. Let's think about that same 6-sided dice. What would be 100% likelihood to happen? That would be a 1 in 6 chance of happening. No, let's think about the 6-sided dice. It is not a 100% chance that the sun will come up. In parts of Canada, the sun doesn't come up for entire stretches of months and months and months. Let's think about the 6-sided dice. So things that can actually happen.
You would land either 1 through 6, you have to land.
Good. What's the probability of landing on a number 1 through 6? That's 100%. Or what's the probability of rolling a number on a 6-sided dice? 100%. That is the difference between 100% and this. Okay? Those are difficult to think through. Let's think through these two real fast. Okay? Just a couple of simples here. All right, here. So there's an 80% chance of rain, a 50% chance of thunderstorms, a 15% chance of hail. Describe the likelihood. There's rain tomorrow. What's the likelihood that it rains tomorrow? This is the percent.
Likely.
Yeah, you'd say that this is likely, right? This is likely to happen. There's a high chance that it's going to happen. Okay, it's close to 75%. So that's kind of your benchmark. 75% is kind of your benchmark. What about this one? Probability that there are. What do we think? Equally likely to happen or not, right? It could rain or it could not. It's equally likely, meaning that it's kind of a toss-up. Okay. And what about this one? That there's hail tomorrow. We would say unlikely. Impossible? No, it could definitely hail tomorrow, but it's not likely to happen. It would be unlikely. So those are the kind of the benchmarks for us. So unlikely and likely. Now let's apply that specifically to what we call theoretical probability. Now, this is some of the probability that you were working with on comp. Okay? We have some numbers. You guys ever seen these kind of blocks before? This is the top-down view of those blocks. You can build with them. They have different numbers and letters inside. So, at this problem, what is the probability of choosing a vowel? Ask each other. Tell each other what a vowel is. All right. Thank you, class. Now, we know what probability is because you watched those probability videos. So you know what, in general, what probability is. What is the probability of choosing a vowel on this? Saeed.
3 out of 7.
Say it again.
3 out of 7.
Why 3 out of 7?
Because there's 3 vowels and there's 7 blocks in total.
Good. E, and O over the total number of blocks. Right? There's 3 vowels out of the 7 totals. And probability is that straightforward. Theoretical probability is the number of positive outcomes, or how many times you have success out of the total number of outcomes. How many outcomes are there? There's 7 blocks, so there's 7 outcomes, and 3 of them are what I want. What's the probability of choosing an X? Why 1 out of 7? There's only one X out of the 7 possibilities. So I ask you this, likely or unlikely? Is it likely or unlikely to choose, or give me the spectrum, right? The spectrum we just talked about. What do you think? To choose a vowel. It's kind of in between unlikely and equally likely, right? So we'd say it's a little unlikely, right? We'd be like, it's a little unlikely. What about choosing an X? It's very unlikely, right? Very unlikely. There's only 1 out of the 7. That's definitely below 25%. Okay? So that's theoretical probability. Theoretical probability is in general just looking at the total number of possibilities and seeing how many of them are what we want. Experimental probability, here's a table. This is us rolling dice, okay? 6-sided dice. A lot of times, standardized tests and things use the word number cube. It's kind of frustrating, but that's just what it is. When we talk about frequency, when we talk about experimental probability, you'll use the word frequency. Frequency is how many times it happened, okay? So, how many times did we roll a 2? How many times did we roll a 2? 4. How many times did we roll a 6? 6 times. How many times did we roll the number cube? How many times did we roll it? Read the problem.
50.
How do you know that, Anna?
Because it says the table, the results of rolling a number cube 50 times.
50 times. So what's the denominator probably going to be for many of these things? 50, because that's the total number of trials. Experimental probability and theoretical probability are very similar to each other. Experimental probability just is dealing with actually doing the experiment. Let me ask you this. What's the theoretical probability of rolling a 6 on a number cube? What's the theoretical probability? 6, because there's 1 6 out of these 6 total possibilities. What's the theoretical probability of rolling an even number?
3 out of 6.
3 out of 6. 2, 4, 6, or 1/2, right? What's the probability of rolling a 4? 1 out of 6. Now, this is what actually happened when we rolled the dice. That's a different probability. It's a different way of looking at probability. So based on the experiment, what's the probability of rolling a 3? Based on the experiment, what's the probability of rolling a 3? How many times do we roll a 3?
8
Out of how many times?
50.
50. So that would be 4 over 25, right? Let's simplify to 4 over 25. Is that 1 out of 6? I don't know, use your calculator, tell me. So how do we check that? Well, you look at 1 over 6, and then you look at this, and you see, are they the same? Are they the same?
No.
No. They're close, though, right? They should be very close.
Yep.
It's kind of cool. It's kind of cool that they're close. We would say, okay, yeah. This would be 1 out of 6 if this was 4 over 24. Right? So we'd say, rolling a 3, did the theoretical probability hold true in this experiment? Yeah. Would we say that this is likely or unlikely to happen, rolling a 3? Based on you have this table in front of you on the worksheet you picked up too. You have the unlikely and likely table. What would you say about this? Likely or unlikely? It's definitely unlikely. It's below 25%. This is 16 point something percent. 16 exactly percent. So we'd say that that would be unlikely. Okay? What's the probability of rolling an odd number?
29 out of 50.
Wait, I thought it was 3 out of 6.
No. Because it's 50 times.
Because in this experiment, this is how many times it happened. 29 is 10 plus 8 plus 5. So 29 out of 50, that's as fully simplified as it can be. Did it happen more than it should have? Or less than it should have? What do I mean by should have? If we roll a dice 50 times, how many times should it land on an odd number? Why 25? Because that's half, right? Isn't the probability of rolling an odd number 3 out of 6? 1, 3, and 5. Those are 3 out of the 6 possibilities, right? So shouldn't it be 25%? Or 25? Well, so what we can say here, and we can make a conclusion about this. The frequency of rolling an odd number in this experiment was more than the probability. Just, we can make a statement about it. Okay. I'm going to turn our attention now to the worksheet that you picked up. So here, I'm going to walk you through, this is what you're going to do for the last 20 minutes of class. You should be able to finish it, I think. I think you should be able to. These are, you just determine the likelihood. So you're using that table. How likely or unlikely are these based on the probabilities that are given, okay? Then at the bottom, this is a frequency table. This is a frequency table where we're going to use that frequency to help us find the relative frequency. The relative frequency is like the experimental probability, okay? It's like the experimental probability. So, how many songs are on this MP3 player? 60, right? That's how many times we did it. So, what's the relative frequency or the experimental probability of listening to a rock song? What is it? 21 out of 60, because there's 21 rock songs. That simplifies to, both of those can be divided by 3, 7 over 20. Let's skip down to rock or country. So rock or country. Rock or country, it's still out of 60, right? But how many of them are rock or country? How many country songs are there?
32.
How many country songs are there?
12.
12. So how many of them are rock or country? 33. Where'd that come from? Well, because it's saying success, or like what we're looking for. I could get rock or country, and that would be what I'm looking for, right? Think about this. I hate dance music. I hate rap music. I only want to listen to rock or country. I like all kinds of music. I only want to listen to rock or country. What's the likelihood that I'm going to listen to a rock or country song? Well, 33 out of 60. Both of those are divisible by 3 as well, so that would be 11 over 20. So that's how we do problems where we're looking for multiple. We just add them up, okay? Rock or country is successful. Let's move over to the back. Here you have several different examples. The first two are a spinner and then random cards. What's the probability that I land on a red? What's the probability that we land on the red? 1 out of 5, right? Because there's 1 red out of the 5 possibilities. What's the probability that we land on a not yellow? 4 out of 5, right? Because there are 4 numbers or 4 colors that are not yellow out of the 5 total possibilities. Let's look down to the bottom. What's the probability that we land on that we randomly draw a striped or white?
7 out of 10.
Yeah, that's what this is saying. It's saying striped and white is what we're looking for. It's out of 8. The bottom. These are all asking for basic probabilities. Careful here on 21. That was going to be the trickiest one. There are 26 letters in the alphabet. What is the probability that a letter chosen at random is in the word mathematics? Okay, just be careful on that one. So your job is to finish this in-class worksheet. Talk it through with your neighbors. When you're done with the in-class worksheet, you can get back to working on your card. I believe that you should be able to finish this worksheet before you leave, if you're working diligently. Okay? All right, let's get working. I'll be around answering questions. This is what we call basic probability.